This is the practice quiz for concept 22. Let's go ahead and take a look at the first problem. A car is currently worth $23,000 and its value has depreciated 4.5% per year. Depreciated means to decrease in value. So when we write an exponential expression, we need to include the starting value, 23,000. The multiplier, because this car is depreciating value, will be 1 minus the percent as a decimal. So if we do 1 minus 0.045, we get 0.955 as the multiplier, and then to the x power. How long will it take for the car to be worth less than $1,000? So we're trying to figure out when will the car be worth less than 1,000. Before the logs unit, the only way we knew of doing this was to guess and check what x is, or time. Now to solve this for x, we can divide both sides by 23,000. If we reduce this is just 1 over 23. We need to use logs because we can't divide by 0.955. This is 0.955 to the x power. So if we use logs, I'm going to introduce log to this side. The reason we're using logs is because the power property of logs allows the exponent to come in front as the coefficient. So x times log 0.955. So when we're solving for x, we're dividing both sides by log 0.955. So x equals, using our calculator, we can evaluate log 1 over 23 divided by log 0.955. So 68.1, or approximately 68.1 years. All right, which of the following expressions represent an investment of $3,257 in an account with 1.2% interest compounded continuously? This is the key word here. We need principal e to the RT. So I know it's not going to be either of these. Here we have r as 0.012, which matches the percent. But here you're adding 1 plus the 0.012. Our formula doesn't have a 1 plus the r, so it's just 0.012 times 5 years. All right, when we sketch a graph of this equation, we can see that this has been transformed over by 1 unit and down by 5 units. So 1, negative 5. And that is our locator point. So we can draw a temporary new xy axis at that point. Since we've already shifted the graph, let's look at the graph without the locator point. 3 times 2 to the x has a starting value of 3. So from this point, I'm going to go up 3. And the 2 is the multiplier, so this graph is increasing with y equals negative 5 as the asymptote, or where the graph is approaching. The domain of this graph is x is all real numbers because the graph is going to the right and to the left in the x direction. All right, part D is solving exponential equations. Here we have 3 times 5 to the x plus 2 equals 29. So we can isolate the exponential by subtracting 2 and dividing by 3. And then here we need to use what we've learned in this unit, which is that in order to move a variable from the exponent to a coefficient, we need to use logs. So if we log both sides, this side is going to be log 9. If we log this side, it's allowing us to move the exponent in front instead of in the exponent. So to isolate or solve for x, I need to divide by log 5 on both sides. So x equals log 9 divided by log 5, which is 1.37. You can always take that answer, plug it back into the original problem, and verify that you solved correctly. All right, the last one here is also an exponential, but the base is e. So this is one way of approaching it. Log both sides to move the exponent in front. You can also approach it by writing the equation in log form. So I'm going to do that here just so you can see what that looks like. If I rewrite this in log form, we have log with the base of e to the power of 2.5x should equal 1,640. This log with the base of e is what we call natural log, which is the button that's on your calculator. So if I'm solving for x, I'm doing natural log of 1640 divided by 2.5 to figure out the value of x. So ln is this button right here, divided by 2.5, and we get x equals 2.96. And again, take that answer, plug it back into the original problem to verify that you've done the problem correctly.